All right, after you open up the Bone Crusher assembly drawing files, this is what the Bone Crusher assembly looks like. As you slide down through, what we have done here is you're going to be asked to create the complete assembly model, bill of materials, exploded drawings, create drawings for each part, including number, name, quantity, animate the entire function, and then create orthographic drawings. We are going to be altering what is necessary for you to submit regarding drawings, but you will need to create animation for the full function before we 3D print parts and pieces. Now, when you come down and you look at the set of parts, these are the parts that you are going to have to create in order to assemble this object. Now, one of the things that you have to be aware of are some of these parts are going to get altered and changed. As I've shown you in the class here before, number 7, students have actually opted not to even use number 7, and they download parts from McMaster-Carr, and then they utilize those downloaded parts. Okay, they go find a thumb screw, they go find a wing nut, and then they create that. When you're looking at part 4, the backside of part 4, where they would put a thumb screw and wing nut through to squeeze this holder that squeezes onto this number 1 shaft here, that needs to be increased or it will break. All right, so you're thinking about making the solid model, but then also creating a 3D printed part. Okay, so those are the things you have to keep in mind as you are looking at these parts. I have traditionally given one part to a team. That team gets to review these drawings. They get to look at this before they tell me the part that they would like to have. Okay? When looking at this, you need to figure out what parts go to what, how they interact, how they get assembled, and then you need to look at the actual information given. Okay? So when you're looking at this particular completed assembly, you need to see what lines up with what parts, how do they interact, so that when you select which part you want, which part is going to give you the most amount of information for other part construction. Okay? All of that is critical, and you need to understand what information is being given in this description, because this is where all the dimensions come from. As you guys start making these parts, you'll start to realize that in order to know where this hole goes in this part number 4, you're going to need to know how the rack aligns to the gear, which then aligns to the shaft, which aligns to this through hole. So you have to really go back through and look at these drawings carefully to see, well, where does this rack alignment really come from? Does this rack alignment come from the hole on the shaft, or does it come from the plate at the bottom? They have to work in harmony, or this whole system will not work. So what parts do you want to be given so you have more information to start from? And then you want to build parts from that point. Each team member generally gets assigned, or you guys choose, well, which parts are you going to work with? Okay? And then you are responsible for creating that part for the team. Then the team everybody on the team is going to make an assembly and make that assembly function with motion in Inventor. Once that's done, you will then be responsible as a team to 3D print the parts. So you have to create the parts separately from each other, but working together. You then build the entire assembly together, but separately. So everybody builds it together. So if one person's part's wrong, it's going to be wrong for everybody. And then you're going to 3D print the parts so that they can be put back together on the table here in the classroom. Okay? So what you said, 4 does give you a lot of information. I would agree. You asked about 13, 10, and 12. Those are pins. In fact, traditionally, we have used wooden dowels. I've even had students, instead of 3D printing those because they get pretty small and pretty weak, they've used toothpicks as a replacement for those. I have accepted that to have that happen. But the rest of these parts have all been 3D printed. And looking over the parts and discussing this, when you look at 4, the top of 4, this object that fits over the shaft, versus the object down here that fits over the shaft, they're exactly the same. They function the same way. You'd have to add material to this back flange so that this back flange doesn't break. Whatever you substitute for 7, I would highly recommend substituting 7 with something else. You can utilize that in the back also, and that would then do both of those. So when you guys start working on these in teams, I will create folders on a Google Drive. I will put the folder links in this assignment. You'll see that in here for linking to your folders. There's going to be an A-Day team and a B-Day team. So hopefully this helps you guys get started on the Bone Crusher project.